All right, we've been waiting for this for 3 sections. Here we are finally at a library of functions, and we're going to also be discussing piecewise defined functions. So, a menagerie of functions. Friendly reminder that the domain of a relation or a function, right, is the set of all possible values that x can take on, and our range is the set of all possible y values. So let's start with the most basic function there is. This is the constant function. Its equation is going to look like f of x equals c, right, where c is a real number. Its graph's a horizontal line. It has 0 slope. Its domain is going to be from negative infinity to positive infinity, so all real numbers. And its range, meaning the y value it can take on, is only going to be c. So if I had y equals 3, its range would be 3. Next we have the identity function. This is the simplest linear equation we can have. This is f of x equals x. So if x is 0, y is 0. If x is 2, y is 2. Its domain goes from negative infinity to positive infinity. And its range goes from negative infinity to positive infinity as well. This is true for most lines that are not constant. For all lines that are not constant functions, their domain and range will always be all real numbers. Next, we have the absolute value function. So the absolute value function is f of x equals x. And this is a function where the output represents the distance from the origin on a number line. We could also write that as the absolute value of x equals x if x is greater than or equals 0, or negative x if x is less than 0. Basically, it's mapping every x value to its absolute value, and that's why we get this perfect V shape. Its domain goes from negative infinity to positive infinity, and its range is from 0 to positive infinity. This is because, friendly reminder, absolute value is never negative. Next, we have the squaring function. This is the simplest. This is also an example of a quadratic function, right? And what this does is this takes each x value and pairs it with its square. So negative 2 squared would go to positive 4. Negative 1 squared would go to 1. And so this is always positive as well. Its domain's from negative infinity to positive infinity. And its range goes from 0 to infinity. And 0 is included in the range. Next, we have a cubic function. So our cubic function looks like half of our parabola flipped over the x-axis. And this is because if I take the cube of a negative number, it stays negative. So negative 2 cubed, negative 8. Negative 1 cubed is negative 1. Because of this, its domain is negative infinity to positive infinity. And its range is also negative infinity to positive infinity. The square root function is a little bit different. So the square root function matches every number with its square root. Now, we are working on the real number line, right? This number line right here represents the real number line. Because of that, I cannot take the square root of negative numbers. I know we've all worked with complex numbers already in this course, but when we're graphing them, we cannot work with negative numbers. So my domain is going to start at 0, because that's the smallest number I can take the square root of. The square root of 0 is 0. Same thing with the range, right? The square root of a positive number is always going to be positive. So the range also goes from positive infinity, from 0 to positive infinity. The cube root function, right? This looks like our cube function flipped and rotated, right? It's defined for all real numbers. So because I can take the cube root of negative numbers and the cube root of positive numbers. So the domain and range of the cube function are also going to go from negative infinity to positive infinity. friendly reminder, it is continuous. Continuous means I can draw it without picking up my pen. Next, we need to talk about the reciprocal function. So the reciprocal function, 1 over x, right? It has one restriction on on its domain, and that is x equals 0, right? If x equals 0, my graph, my function would be undefined. So at x equals 0, we get an asymptote. Now, because my numerator is never going to be 0, my graph's going to get closer and closer to the line y equals 0, but never cross it. So my domain and range are both exclude 0. We have asymptotes. That means like lines you cannot cross, lines your graph will not cross at these points as well. So we have asymptotes at x equals 0 and y equals 0. And we'll talk more about how to calculate horizontal and vertical asymptotes later on in this course. Last but not least, I want to talk about the greatest integer function. This is probably my least favorite function, if we're going to be honest, because it's really choppy, right? It's still a function because it passes the vertical line test, but it just doesn't have the same je ne sais quoi that the cube function or the squaring function have, right? So what the greatest integer function does is it assigns x to the greatest integer less than or equal to any real number in its domain. So, for example, the absolute value of 5 is 5. The greatest integer of 5 is 5. The greatest integer of -2 is going to be -2. The greatest integer of 0 is 0. Here's where it gets trippy. If I have 6.45 or 6.5 or 6 9/8, not 9/8, 9/10, it's going to map that back to 6. Okay? If I have 3.7, that's going to map it back to 3. So here's 3.7, it's going to map it to 3. If I have -1.7, which would be like right here, it's going to map it back to -2, right? It goes to the lowest one. Same with -1.2, it's going to map it to -2 as well.